All right, so we are in Algebra 2, Lesson 10-1. We're on a brand new unit. This whole unit revolves around fractions. Fractions when it comes to functions. So those are called rationals. If you ever see the word rational in your mind, automatically convert that to the word fraction. Today's date is Thursday, March 26, 2020. I know that we haven't really done that many lessons in this class since online instruction has begun. But in terms of the procedures, if you have a question, you need to do a raised hand. And if you want to participate in the class, you give me a yes. That way I can distinguish between the two. If you leave your the yes on, if you don't take it down, I assume that you're ready for the next problem. So if you answer a question, I won't put the yes down for you. You'll have to take that down yourself unless you want to participate in the next problem, then you leave it up. All right, so let's practice that. So obviously we're doing simplifying rational expressions, the easy version. Then tomorrow's lesson 10-2 is going to be the medium version. And then on Monday when we come back, we're doing 10-3, which is the hard version of this lesson. So there's a clear progression here for the next 3 days on just simplifying these rational expressions. So can someone give me a yes in the nonverbal feedback? If you click on participants, you can click on that. A yes will indicate that you are ready to read the objective to me. So, it was a tie there. I'm going to give it to Beverly.
Simplifying rational expressions that have common monomial factors.
Yeah, so that word is pronounced monomial, and it means I have one term. I'll write above here, one term. You're not going to factor out a binomial. You're going to factor out a monomial. And yeah, tomorrow is going to be the medium version. We're going to factor out binomial factors. All right, so with that, let's start with some vocab to get us started. A rational expression. I told you already what a rational is. What word should you be converting rational to? Beverly again?
Sorry, can you say that again?
What should you convert the word rational to in your mind? Because you left your yes up, so I assume that you're still ready to go.
Oh, I didn't. Sorry, I didn't mean to.
Oh, no worries. Okay, that's my bad. Yeah, Ellery.
How do you take it down?
You go, I think there's like a clear button at the very right.
I think you just press on it again. That's what I did.
Yes, again, okay.
You should convert rational to fraction.
Yeah, so a rational expression is an expression with a fraction. So I'm going to say fraction. Like x squared over x plus 1. See, there's a fraction. I have some variables happening there. I have a monomial in the numerator and a binomial in the denominator, but that is a rational expression now. And the word expression means I don't have any equal to signs. So I'm not dealing with any equation for the first 3 lessons. I'm just dealing with expressions. All right, so an undefined. That's when the denominator is equal to a certain number. And that's kind of like the swear word mathematics. You're not allowed to say this word. That's when I divide by what? Who has a yes in the nonverbal feedback? I have one hand up. I guess I should be thinking about trying to call in more people. We do have a big class. What is the swear word when we divide by what in mathematics? You probably learned this word, or I'm using word in air quotes if you see my camera. We use this word probably starting in, I don't know, like the 3rd grade. You're not allowed to divide by this number ever.
0?
There should be a choir's hand, but yes, you are correct. It is 0. It should be the yes in the nonverbal feedback. The reason that I do that instead of just blurting out answers is to give people time to think.
Okay, so it's over here.
Yeah, in fact, maybe we should practice doing that. I'm gonna go ahead and recording. When I say simplified, that means that the numerator and denominator have no like terms. So I kind of ran out of room here. So I'll say have no like terms that can be canceled out. So they can't be reduced. The numerator and denominator have no like terms, therefore they can't be reduced. And I should maybe make the no like terms that are being multiplied. I'll put that in parentheses. Or maybe a circle with a multiply. Those like terms have to be multiplied because that's the only thing that allows you to cross out things in the numerator and denominator. All right, and finally, domain. We've talked about domain quite a few times, so I need a yes with the nonverbal feedback. What is the domain? Is it all the things that can go in, or is it all the things that can come out? Who has this? Or maybe even a more formal definition than what Mr. Sindel has. Again, a yes will tell me you are ready to participate. You know what domain is. I will cold call. I have promised I will. And I already gave you a 50-50 shot. Is it the things that go in or the things that come out? No one wants to participate. Maybe you're still copying down the simplified numerator and denominator. Yes, India.
Is it the things that go inside?
Yeah, the things that go in. So it's all possible inputs. And for us, that's going to be all the x values. And then all the y values are the things that come out. The y values are called the range. So the one thing that I want to make a note for the domain is choose all the inputs that make the function defined. So if there's an input, if there's an x value that make the denominator 0, then that is the only thing that's not going to be in the domain. So I'll write down things not, maybe I should capitalize not, things not in the domain. Those
Isn't that what the next line down is?
Oh my gosh, you're totally correct. Gotta have
I don't get it.
You don't get it, Lyria?
Like, what? By inputs, what do you mean? And like, domain? I don't know.
So domain is just a word that I'm going to be using, and I want you to know what I'm saying when I say domain. And it'll make more sense once we actually start using the domain. So in example 1, I'm going to list all the values that make the expression undefined, which means my domain is everything except that value. So the only reason that I'm starting out with vocabulary is when I use the word domain or I use the word rational expression, I want you to know what I'm talking about. And
what does it mean when something's undefined?
If it's undefined, that means that the denominator is equal to 0. So if I say, I can give you a tiny little example problem as a preview. So if I have 1 divided by x, if I plug in x is equal to 0, that means that this problem is going to be undefined. Or if I had a different problem, if I had 1 over x minus 1, if I plug in x is equal to 1, now this expression right here is undefined. So yeah, the definition of undefined is whenever the denominator is equal to 0.
Okay.
Okay, so the only values of x that are not in the domain are the ones that make the fraction, and I've said it like now probably 4 or 5 times. It's one of these words up here, one of those 4 things that I've been talking about. Someone that has a yes, India has it, Ellery has it. I need to hear from more people though. All right, this lesson is going kind of slow. I'm gonna start cold calling. Yes, Caroline, go for it. Which of these 4 words goes in this blank?
I don't know.
You have a 25% chance if you have no clue at all. Go ahead and guess one of them.
Undefined? I don't know.
Exactly, undefined. All right, so I'll read that once again. The only values of x that are not in the domain are the ones that make the fraction undefined. And I can use the word expression here instead of fraction. So eventually we're going to be listing the domains for these functions. In those domains, we want to exclude all of the values that make it undefined. And again, I know that I'm throwing around words and you have no connection to what they refer to in terms of mathematics. Well, once we do an example problem, I think it'll become a little bit clearer. Okay, and then before I actually move on to the procedure, I need to talk about a really common mistake that I saw last year in Algebra 2, which is canceling out expressions. So the first thing, the most important things is if they're being added, I can't cross them out. So if you kind of come down here to a misconception, so I'm on this line right now, I'll let you guys copy this down a little bit. The biggest misconception I see when I have a fraction like x plus 3 in the numerator and x plus 5 in the denominator is people saying, oh, I see an x in the numerator, cross it off, and I see an x in the denominator, cross it off. No, this is wrong. If they're being added or subtracted, you cannot cross them off. When can we cancel out expressions? When can we start crossing things off? Not with addition, not with subtraction, but with only one keyword here. Who has it with another quiet yes? India has it. Ellery has it. Yes, Lyria.
Multiplication.
There it is, multiplication. So when they're being multiplied. All right, so there's a very, very simple procedure for how to do the problems that you're about to see. And you've seen this before. So whenever we factor things, there's always two steps. I should have done step 2 right here. So step 1 is 3 letters, and then step 2 is this symbol. So what are these 2 steps whenever we're trying to factor? We're going to factor the numerator and we're going to factor the denominator. What are the 2 steps that I always have been telling you over and over again when it comes to factoring? Or you can give me any one of those steps. Again, sorry, Ellery, thank you for raising your hand patiently. I'm going to call on someone that hasn't participated. You can leave your hand up, though. It shows everyone else that you're ready to go. No one? All right, I'll give it to, I don't know, Oscar, sure. Oscar, what are the 2 steps when I am trying to factor?
I don't know.
What is do you remember doing this symbol?
Oh yeah, the ninja star thing.
Okay, so then ninja star is that second step. Everyone write it down. And what about the first step, Oscar? Do you remember the thing that we always had to do before?
The what?
There was one step that we always had to do every single time before ninja star. There were 3 letters here. Greatest.
Oh, is it the GCF?
It is indeed the GCF. Factor out the greatest common factor, and then step 2 is to apply the ninja star. Well, thank you, Oscar. I can't cold call on you again. But that doesn't mean that you shouldn't pay attention. It means you should keep paying attention. Step number 2, we're now going to list all the values of the variable that make it, and then again, it's that same word that we've been using over and over when that denominator is equal to 0. Can someone fill in the blanks here? In fact, I'll fill in one of the blanks for you. All the values of x that make it, and then what's that word that means that the denominator is equal to 0? It's kind of the big word for this unit. I'm going to be using over and over and over again. Not enough hands. All right, I'm going to cold call on, who have I not talked to yet? Emily.
Equal.
So what's the word that means that the denominator is equal to 0? It's one of those 4 words that I defined up above. When the denominator is equal to 0, which of those 4 things is it?
Undefined.
Undefined, exactly. All right, and then finally, step number 3 is you're allowed to start canceling out common expressions, but only if they're being, what's the operation again? And I'm gonna go ahead and just call on people because I'm saying the same thing like 7 times, and if we're not getting it, that's the problem. Okay, Cheyenne, go for it.
What was the question?
So I'm gonna cancel out the top and the bottom, the numerator and denominator, only if they're being, and then what's the operation here? Is it adding? We wrote it down already up above. You can only cancel out expressions
Yeah, only if they're being multiplied.
being multiplied. Thank you. All right, and I don't know if I'm having bad pacing or what's going on. So if you guys tell me go slower or go faster, I am responsive to that. I'm like constantly looking at the participants window, seeing that India has a yes. If I'm going too fast, you do need to let me know if I can slow down. If you feel like I'm not going fast enough, you can also let me know. All right, so we have the procedure down. Let's finally do our first example. I know that we already have been going for like 25 minutes now. Our first example. So I'm going to give you an expression. It looks like this. In the numerator, I have x to the power of 3 minus 3x to the power of 2. In the denominator, I have 4x squared minus 5x. All right, so I'm doing step 1. Factor out the greatest common factor, and then I'm going to ninja star this. Luckily for all of today, this ninja star, not doing it. I can't spell doing. Ding. We're not doing ninja star today because I'm doing it as simple as possible. I'm literally just doing step 1. Greatest common factor, you're done. The greatest common factor will be the monomial factor from our objective. All right, so here we go. Quiet raised hand, or quiet raised yes. How do I factor out the greatest common factor in the numerator and denominator? If you know how to do that, go ahead and do it. In fact, I think I've taught you enough where you can do example 1 and example 2 and example 3, be done with this, and then start working on the homework before we're even done with the notes. So by all means, you can go ahead of us. But I need to see more people participating. Oh gosh, okay. I hate cold calling because I don't know, studies have shown that it's not very effective, but I need to hear from everyone. I need to check in with everyone. All right, what's the greatest common factor for the top? All right, cold calling on Aurelio.
Sindel.
Yep.
How you doing?
He might not even be here because his video is turned off. Okay, not
Are
Aurelio.
you going to be watching me on the big screens one day, Sindel?
I hope so. Let's try Leo. Leo,
No.
what's the greatest common factor for either the top or the bottom? Give me either one of them.
Jaden, can I see Clooney?
She's lucky right there, just looking at him. I'll bring her towards the end.
3. I don't know.
I can barely hear you, Leo. Is it maybe that you're using a weird microphone or something, or maybe just if you could speak up? It's hard to hear.
3.
Not quite. So yeah, you're right in thinking we need to be looking at the coefficients. So the coefficients are 1 and 3. Darn, okay, so I can't factor out any of the coefficients. So the next thing that I need to think about is the powers. What is the smallest power between x to the power of 3 and x to the power of 2?
X to the power of 2.
There it is. So Leo's found that the greatest common factor is x to the power of 2. And Leo, when we factor out our greatest common factor of x squared, what do we have left over when I factor that out?
I'll give it to Aurelio.
Leo, I think you can still do this. You got this. Come on, Leo.
Give it to Aurelia.
I keep hitting unmute when you hit mute, so it ends up muting you as soon as you click it. So Leo, if I factor out x squared, that means I'm dividing each of these two terms by x squared, which is, if you're using my rules of exponents, that essentially means I'm subtracting that 3. I'm subtracting 2 from 3. So I'm left with Leo?
Yeah.
I'm left with
1.
1. Yeah, so x to the power of 1, and that simplifies to just x. So minus, and I have to leave that coefficient. X to the power of 2 divided by x to the power of 2, Leo, is
1.
Chicken tenders.
nothing. So done. Leo has now factored out the greatest common factor for the numerator. I need someone to factor out the greatest common factor for the denominator.
All right, so I turned in my participation card.
Your card has been taken. I can no longer cold call on you. You are correct. All right. I'm going to give it to Atziri.
No.
So the first question is, what is the greatest common factor for this denominator? It's very similar to the numerator. What is the smallest power that I can factor out?
Wait, what's the question?
So the question again is, what is the greatest common factor of 4x squared and 5x? What's the biggest number that can divide both of those by? So I'll walk through it with you. So 4 and 5, there's nothing that I can factor out because those are called co-prime. I can't factor anything out. So the next question is, well, what's the smallest power that I have between x squared and x, I guess technically to the power of 1? Which one of those is smallest?
It's the power of 1.
X to the power of 1. So I'm going to factor out that x to the power of 1. If I simplify it, I'm really left with just x, but we'll leave it x to the power of 1 for now. Now that I've factored out x to the power of 1, I'm going to subtract this 1 from 2 and from 1. So what goes on the inside here, Atziri? I have 4x squared, and I'm going to subtract a power. I'm left with I still have the 4, but x to the power of 2, I'm going to go down a power, and it's going to go x to the power of
4x.
Not to the power of x, but to the power of
1.
1, exactly. And then you're almost done. 5x, and then I'm going to divide by x. I'm going to subtract 1.
How would you grade yourself in your own butt wipe?
Jaden, I've been muting you over and over. You've lost all of your points.
Sorry, I thought it was muted. Sorry.
-5.
Yep, -5. Perfect, done. Thank you. All right, so Atziri and Leo have factored our numerator and denominator. Now we need to do step number 2. We just did step number 1. I know that this is taking, okay, I'm going to try, guys. Thank you for the feedback. I'm going through this. I'm going to list all the things that make my function undefined, my expression undefined. So I'm setting this denominator equal to 0. I'm on step 2 now, so I'm saying x times 4x minus 5 needs to be set equal to 0. I'm going to go ahead and just take over because we're going to run out of time. How do I do this? I use the zero product property. The zero product property basically states that this x could be 0 or this 4x minus 5 could be 0. I'm literally going to write what I just said. This x could be 0 or this 4x minus 5 could be 0. And then I'm going to solve for both of these. Luckily, this x equals 0 is solved. So that's one of the things that makes our function undefined. And if you, I know that a lot of people are still struggling. What does undefined mean? Here, let me simplify this as much as I can. These are bad things. Let's find all the bad things. One of the bad things is x equals to 0. This is bad. This makes me divide by 0. What's another thing, another x value that's bad? Well, if I solve this, that's another bad thing, another undefined value. So if I add 5 to both sides, really quickly, add 5, then I'm left with 4x is equal to 5. Divide both sides by 4, and I'm left with x is equal to 5/4. So I'm going to circle them, not box them, because that's not my final answer. But these are both of the values of x that make this expression that I started with undefined. Those are my bad values. That was step number 2. Now I'm on step number 3. Step number 3 is to cancel out anything that is being multiplied. So x minus 3 and 4x minus 5, these don't look the same, so I can't cross them off. So those are going to be in my final answer. Nothing that can be canceled off. But x squared and x to the power of 1, things there can cross off. In fact, this is just using rules of exponents. Whenever I have something, this is the rule that I'm invoking, x to the power of a divided by x to the power of b. If I have the same base to some power, this is going to be x to the power of a minus b, which means I'm going to subtract the power of 1 from the power of 2. So this is equal to x to the power of 1, because I'm subtracting this power of 1 in the denominator from the power of 2 in the numerator, leaving me with x to the power of 1. And then I'm going to rewrite everything else. By the way, x to the power of 1 is just x. So it's x times x minus 3 divided by 4x minus 5. I have now simplified my fraction. Yes.
So, actually, never mind. I got it.
Okay. So this is my answer. This is how I simplify it. But it also says list the x values that make my expression undefined. I listed them already. They're down here. X equals 0. That's one of the that's one of the x values that makes my function undefined. And x equals 5/4. It's asking me simplify it. Done. That's what's in my box. And list the values of x that make it undefined. We did that. Those are our bad x values. We're done. All three of these things that I circled and boxed, those are our answers. In Khan Academy, you'll be having a multiple choice option for all the x values that make it undefined. Okay. I'm going to move on to example number 2 unless someone wants to tell me to slow down in the nonverbal feedback. Otherwise, I'm moving on in 10 seconds. Okay. No one's telling me to slow down. I'm on to example number 2. And unfortunately, I have to kind of rush through this again because we have 4 minutes left of class. But luckily, the video is going to be posted online if you need to rewatch it. So it's the same prompt. Simplify the expression, and then list the values that make it undefined. Find the bad values, simplify this thing. To simplify, we factor. I can't do anything with the top. It's already factored as much as possible. But the denominator, I can move around. So this is 33k in the numerator. But in the denominator, I can factor out the greatest common factor. I always have 2 steps when I factor out the greatest common factor. I look at the coefficients, and then I look at the power. So the coefficients, 11 and 22. The greatest common factor between 11 and 22 is 11. So I say, okay, 11 is being factored out. And by the way, I can't factor out a k because this term, negative 22, does not have any k value to factor out. So the greatest common factor between 11k and 22 is 11. So factoring out that greatest common factor of 11 leaves me with, okay, so 11k divided by 11 is k. This minus 22 divided by 11 is minus 2. I have now factored out the greatest common factor in the denominator. And, oh, okay, I now see 33 and 11. That can actually be reduced. So I'm going to, I don't want to skip to step 3. I'm going to do step 2 right now. Step 2 is saying, set this denominator equal to 0 to find the bad values. So I'm working on bad values right now. The bad is saying I'm going to set 11 times k minus 2 equal to 0. Okay, well, first step, let's divide both sides by 11. Divide by 11. Okay, 11 is gone, and I'm still left with 0. So 0 is equal to k minus 2. Okay, well then solve. I just add 2 to both sides, and I'm left with k is equal to 2. That is one of the bad values. Done. It said find the values that make the expression undefined. The values of 2 will make the expression undefined. Okay. Then I'm going to move on to step 3, and I'm going to simplify this thing by cross-canceling. I can rewrite this as 11 times 3. That's the same thing as 33. And I still have to say times k. And in the denominator, I'm just going to rewrite that as 11 times the quantity of k minus 2. Notice that we have an 11 in the numerator and 11 in the denominator. I'm going to cross both of those out. And then this is going to be equal to 3k in the numerator and k minus 2 in the denominator. I have simplified it, which is what it's asking for, and I have listed the bad values that make it undefined, that make the denominator equal to 0. That is the solution to example number 2. We have 1.5 minutes. I don't know if I can get through all of the example number 3, but I'll go kind of fast. By the way, when we finish with my class, we go into Mr. Godoy's class for advisory. Beverly, question, go.
So on example 1, why did we do it different when you set it to 0? You put 0 and then you put the part that was in the parentheses in equal to 0.
So whenever I have 2 things that are multiplied together to equal 0, both of those things are set equal to 0. In this case,
on the bottom,
one is being set equal to 0.
yeah.
I could try to say 11 equal to 0, the left-hand side, but that doesn't make sense. 11 can never be 0.
So only if it's a variable?
Only if it's a variable. That's the only thing that could. Oscar.
Oh, sorry.
Did that answer your question, Beverly?
Yeah.
All right, and then Ellery.
Hold up, sorry, I was on mute. But you have like 0 divided by 11, and the next step that just equals 0. How did you get there?
So as a general rule, 0 divided by anything other than 0, so 0 divided by 100 is 0. Or if I say 0 divided by 1 is...
Okay, that makes sense. I was just being dumb. All right.
All right, and then I'm out of time. I will finish the recording for example number 3 and post it online if you want to see it. Example number 3 combines example 1 and 2 into the same problem where the greatest common factor is a variable and it's also a coefficient at the same time. All right, but that concludes the notes for Zoom. I'll finish these notes in about an hour. I'll see you guys in Mr. Godoy's advisory class within about the next minute. All right, so yet again we are going to factor. The greatest common factor between the coefficients 18 and 4 is 2. 4 doesn't go into 18, 4 does go into 20 and 16, but not 18. So 2, and then in terms of the lowest power, it got cut off here, but this is just a y to the power of 1. I know it looks like it got cut off and it might have been to the power of 3. No, it's just y. So this is going to be 2y to the power of 1 because that is the smallest power. So that is the greatest common factor. When I factor the greatest common factor out, 18 divided by 2 is 9, and then y to the power of 2 divided by y to the power of 1 means I'm doing 2 minus 1, and that's just y to the power of 1. And then I'm going to copy the sign in between. I have now 4y to the power of 1 divided by 2y to the power of 1, that's just 2. All right, so let me see if I can get rid of that. No, it's not going to let me. Just wanted to grab certain things. Okay, whatever. And then from here, I'm going to factor out the greatest common factor for the denominator. Again, for the coefficient between 6 and 2, the greatest common factor is 2. I don't know what happened to the 2 there. The greatest common factor between y to the power of 1 and y to the power of 3 is y to the power of 1. Again, I just choose the smallest one. So that is the greatest common factor. When I factor that greatest common factor out, 6 divided by 2 is 3. Again, this 6 divided by this 2. And then y to the power of 3 divided by y to the power of 1 means I'm doing the power of 3 minus the power of 1, which is y to the power of 2. And then I copy down the sign in between. It was a minus sign. And then I do 2y to the power of 1 divided by 2y to the power of 1. Well, anything divided by itself is 1. So there it is. I factored out the greatest common factor. That is step 1 complete. Step 2, I need to set this denominator equal to 0 to find all of the bad values, aka the values of y that will make this rational expression undefined. So I say this 2y times 3y squared minus 1. Again, I'm not writing the power of 1, because I'm just simplifying my answer. That needs to be set equal to 0. In order to solve this, I need to have 2 different problems. I can say that this 2y is 0, or this 3y squared minus 1 is 0. So let me write that down. 2y is equal to 0, or 3y squared minus 1 is equal to 0. And then I solve both of these. So when I solve this left side, I get y is equal to 0. Divide both sides by 2, right? Then I add 1 to both sides. This is now going to be 3y squared is equal to 1. From there, yeah, divide both sides by 3. And so divide by 3, divide by 3. Now I have y squared is equal to 1/3. And I know that it's not simplified, and there's someone out there that's like, you can't have a radical in the denominator. I'm going to leave it as the square root of 1/3. So y is equal to the square root of 1/3 is one of the bad values. So let me circle the 2 bad values. One of the bad values is the square root of 1/3, and the other bad value is 0. Both of these y values will make this expression undefined. All right, that was step number 2. I'm on to step number 3, which is cross the things out that look the same, that are being multiplied. This 2y is being multiplied by this 9y plus 2. So I'm going to cross off that 2y and 2y. And after crossing it out, I guess I'll rewrite it without the 1 to make it a little bit more simple. The correct answer here is 9y plus 2 in the numerator. And in the denominator, we have 3y squared minus 1. That is the fully reduced form. All right, and that concludes notes 10-1. I'll see you guys tomorrow.